Okay, today we're going to be looking at the notes over continuous functions. And remember, continuous functions are different than discrete because discrete are the ones that have points and have restrictions on it. Where continuous, the only restrictions it could have is either on one end or both ends. Otherwise, they could stretch out forever and include everything in between. So when we're looking at the domain and range of continuous functions, a set of data is said to be continuous if the values belonging to the set can take any value within a finite or infinite interval. Usually requires a measuring device written using inequalities. So less than, greater than, less than equal to, greater than equal to. Occasionally, not very often, would we use the actual equal sign. In a verbal description, the bicyclist is going on a ride that lasts 4 hours and traveling at a consistent speed of 20 miles or 20 kilometers per hour. The distance traveled, y, is a function of time spent biking, x. So we know that our distance is going to be our range, while biking and the time is going to be our x value. So that's going to be pretty easy to understand on our x value because our x value, we know how long they biked for. They biked for 4 hours. So our domain is going to be 0, because you got to start somewhere, is less than equal to x, is less than equal to 4. The distance, again, starts at 0, is less than equal to y, is less than equal to, we have to figure out how far they rode. Well, they rode 20 kilometers per hour. They rode for 4 hours. So we take 4, multiply it by 20, because that's the speed per hour, and they traveled for 4 hours. So that's 80 kilometers. If we want to go ahead and put this on a graph, I'm going to make this as simple as possible. So this right here is going to be time, my x value. My y values is going to be kilometers, distance in kilometers. I'm going to count this by 10, 10, 20, 30, 40, 50, 60, 70, and 80. And for my time, just so I can spread it out so you can see it a little bit better, I'm going to do it in half hours. So every other one, so this right here is going to be my first hour, and that would be a half hour. The next one's 2, 1, 2, 3, 1, 2, 4. If you went 1, 2, 3, 4, there's nothing wrong with that. I just wanted to spread it out a little bit so you could see it a little bit better. I start at 0, 0. I end at 4 hours and 80 kilometers. And every 1 hour, I would travel 20 kilometers. So 1 hour, 2 hours, 3 hours, and 60. And because this is continuous, I'd actually connect these. So I'm going to go ahead and connect them a little bit here. Use another piece of paper to help me out. And I kind of missed, but that's okay. But I don't go beyond there because I stopped biking at 4 hours. In the table, it says the table shows some ordered pairs that belong to a linear function. So, two key points is one, these are not all of the points that are given to us. There's only some of the points that are given to us. And all they tell me is that it's a linear function. Remember, a linear function is just a line. That's it. I don't know anything else. I don't know any restrictions on this at all. So because there are no restrictions, that means there is no limits on the domain or range. And in fact, I can use all real numbers on both my domain and range. I don't know anything that's going on with this linear function. All I know is my x values change, my y values change. So therefore, it's going to be a line. It looks like actually the line is going down based on that the x's are increasing while the y's are decreasing. That's all I know. I also know that the domain and range could be any number whatsoever. Looking at an equation, y equals 3x plus 4. Again, this is a linear function. There are no restrictions on this whatsoever. And because it's a linear function, if I actually graph this, it'd go through some point right here at 4, and it would go up. And that's all it is. It's a line. I have no restrictions on my domain. I have no restrictions on my range. So it's all real numbers. Over here at this graph, this is a graph that you've seen before, but we haven't talked about. This is a quadratic right here. It looks like it has stopping points here and here. So my domain stretches this far. So it starts at 0, is less than equal to x, is less than equal to 3. My range starts here and goes all the way up to here. It includes everything in there. So my range starts at 0, is less than equal to y, is less than equal to 40. I don't know. I started writing y there again. I don't know why. I'm sorry about that. And that's it. Because these have stopping points here, that's it for my inequalities. They're done. Now this one's a little bit tricky because this is an open circle. So because the circle is open, I do not include it. So my domain, my x value, starts way over here at -5. It is strictly less than, no, not less than equal to, x, and stretches all the way over to here, which is 3. So less than equal to 3. My range starts here, so it starts at 1, is strictly less than y, and stretches all the way up to here, which is 3, and less than equal to 3. And that's it for that one. Here I have an exponential function. Because of this exponential function, what I know is it looks like it goes on forever, increasing forever. But what it looks like here is that I do not have an arrow. So it stops here. Therefore, my domain starts here at 0, and it goes on forever. I include 0, less than equal to x, less than equal to, which I'm just going to put the infinity symbol. Goes on forever. My range does not start at 0, it starts at 30, right here, is less than equal to y, is less than equal to, again, it's going to infinity. These are the different notes for the domain and range of continuous functions.